You may get the image at a particular distances when you place the object at a certain distance. So when we place the object at different places, then we will get the image at different places. Okay, so do you find any relation between the object distance and image distance? Yes, we can find the relationship between object distance and image distance. So here the object distance is showed by u and the image distance is showed by v. So now we are deriving one equation. That equation is showing the relationship between object distance, image distance and focal length. So what is our topic name? Derivation of formula for curved mirrors. Okay, so once you observe this figure, first figure, observe a ray coming from the point O, which is on the principal axis of a mirror, falls on the mirror at a point A, which is at height h from the axis, and after the reflection passes through the point I, which is also on the axis. So here once you observe this first picture, at O one object is there. From the object O, the ray falls on the concave mirror at a point A. Okay na? A is at height h from the principal axis. So here P to O is, that is principal axis, no? So from the principal axis the point A is at h height. Okay, so the ray from the O, okay, from the O the ray is falls on the concave mirror at a point A, and after falling on the mirror it is reflecting, no? The reflected ray is pass through the point I. Once you observe this I, where is that I? Here. Okay, so when it is passes through the point I, that I is also on the principal axis. Okay, so here AC is the normal. C here, there, no? Between O and I one point C is there, no? So that C to A, okay, C to A one dotted line is there, no? That is AC, that is called as normal. Okay, how to draw the normal for curved surfaces we discussed, no? Okay, that AC is the normal. Okay, next the angle of incidence OAC and the angle of reflection CAI are equal, and they are denoted by theta in the figure. So here OAC, it is called as angle of incidence, and CAI, that is called as angle of reflection. We know this. Okay, so these angles are denoted by theta. Line segment AP dash is the perpendicular drawn to the axis from the point A. Once you observe the principal axis. So here line segment AP dash, okay, near the pole one more point P dash is there, no? Okay, so from P dash to upside A we drawn one dotted line. Okay, that is nothing but a line segment AP dash is the perpendicular. It is a perpendicular drawn to the axis from the point A. Okay, so now we can observe the three right angle triangles. Okay, if we draw one line segment AP dash perpendicular from, okay, if we, the line segment AP dash is the perpendicular drawn to the axis from the point A, then we can observe three right angle triangles. What are the three right angle triangles? A, O, P dash. Okay, that is one right angle triangle. And one more right angle triangle, what is that? A, C, P dash. A, C, P dash. And one more right angle triangle, what is that? A, I, P dash. These three are the right angle triangle we can observe if we draw a line segment AP dash is perpendicular to the axis from the point A. Okay, So let the angles at the vertices are O, C and I of three triangles be alpha, beta and gamma respectively as shown in the figure. Okay. So let the angles at the vertices of O, C and I of the three triangles are alpha, beta and gamma. Okay. We know that in a triangle, sum of the interior angle is equal to the exterior angle. So, in a triangle, sum of the interior angle is equal to sum of the exterior angle. Okay, sorry. So, in a triangle, sum of the interior angle is equal to the exterior angle. Okay, so here from the triangle AOC, once you observe the triangle AOC, this is one of the triangle, no? So, in this, sum of the interior angles, okay, so that equal to exterior angle. Here which is exterior angle, so that beta is exterior angle, no? So that beta equal to, we can write alpha plus theta. Okay, beta is exterior angle, so remaining two are interior angles. So in a triangle, sum of the interior angles equal to the exterior angle. So from the triangle AOC, we can write like this: beta equal to alpha plus theta. Okay, so now transport this alpha left side, then what we can write? Plus alpha will become minus alpha, no? So then we can write theta equal to beta minus alpha. Theta equal to beta minus alpha. Next, from the triangle ACI, from the triangle ACI, from the triangle ACI, we can write gamma equal to beta plus theta. Okay, sum of the interior angles equals to exterior angles now. So from the triangle ACI, we can write gamma equal to beta plus theta. Okay, so here, so from the triangle ACI, we are written gamma is equals to beta plus theta. Okay, we know that theta equal to beta minus alpha. Theta is equals to beta minus alpha. Okay, we know that theta is equals to beta minus alpha. This we are written from the triangle. This we are written from the triangle AOC, no? Okay, theta is equals to beta minus alpha. So now substitute that theta is equals to beta minus alpha in the above equation. What is that above equation? From the triangle ACI, we got gamma is equals to beta plus theta, no? So in gamma is equals to beta plus theta came, no? So in the theta place, we substitute theta is equals to beta minus alpha. Okay, then what will come? Gamma equal to beta plus beta minus alpha. Okay, so then gamma is equals to beta plus beta, 2 betas. Okay, gamma is equals to 2 beta minus alpha. So now transport this alpha left side. What will come? 2 beta equal to alpha plus gamma. 2 beta equal to alpha plus gamma will come. This is equation number 1. Okay, remember this equation. By this equation only we will get the relationship between object distance, image distance and focal length. Okay, so remember this equation: 2 beta is equal to alpha plus gamma. Next, what happens when height h becomes very small? Once you observe the figure, second figure, if the height h becomes small, then what happen? Okay, when height h becomes very small, this p dash may coincide with p. So when the height h becomes very small, p dash coincide with the p, okay, which is the pole of the mirror. Okay, p dash may coincide with point p, which is the pole of the mirror. Then we can say p dash o equal to po. So when the height h becomes very small, p dash is coincide with the point p. So then p dash o equal to po we can write, and p dash c we can write equal to pc. P dash c equal to we can write pc, and p dash I equal to we can write pi. P dash I equal to we can write pi. The angles alpha, beta and gamma becomes very small as shown in the figure, as shown in second figure. So when the height h becomes very small, then the angles of alpha, beta, gamma also becomes very small, which are showed in the second figure. Now once you calculate the tan values of the angles alpha, beta and gamma, okay, now we'll calculate the tan values of the angles of alpha, beta and gamma. Okay, so from 10th class trigonometry chapter in maths, you learn in a right angle triangle the ratio of opposite sides and adjacent side is known as tan. Okay, the ratio of opposite side and adjacent side is known as tan. Okay, so in a let's calculate the tan values of the alpha, beta and gamma. Okay, now calculate the tan values of the alpha, beta and gamma. So in a right angle triangle, the tan values of the acute angle is the ratio of the length of the opposite side to length of the adjacent side of the acute angle. Okay, so here p dash is assumed to coincide with p. P dash is coincide with p. Then we have, so from the right angle triangle AOP dash, what we can write tan value? Okay, so from the right angle triangle AOP dash, we can write tan alpha equal to p dash a by p dash o, p dash a by p dash o. Okay, so here p dash a that equal to h, no, p dash a that equal to h, so h by p dash o. Okay, so h by p dash o that equal to h by po. Why we are written po? Why? Because here when the height h becomes very small, then p dash is coincide with p, no, that's why. Okay, so from the right angle triangle AOP dash, we can write p dash tan alpha equal to p dash a by p dash o that equal to h by p dash o. Why we are written h? H is nothing but p dash a. P dash a is equals to h by p dash o that equals to h by po. Now we will calculate tan beta. Okay, so here from the right angle triangle ACP dash, what we can write? Tan beta equal to p dash a by p dash c that equal to h by p dash c. H is nothing but h equal to p dash a, no, that's why we are written h by p dash c that equals to h by pc. Okay, next from the right angle triangle AIP dash. Okay, what we can write? P dash a by p tan gamma is equals to p dash a by p dash I that equals to h by p dash I equal to h by pi. So when an angle theta becomes very small, means that is close to 0, the values of numerators becomes very small. Okay, so here when an angle theta becomes very small, then means when it is close to 0, the values of numerators becomes very small. So you can observe this in second figure. So then the values of tan theta becomes very small, means that is close to 0. So the value of tan theta is taken as theta. Okay, so the value when an angle theta becomes very small, close to 0, the values of numerators becomes very small. So you can observe in second figure also. Then the values of tan theta becomes very small, that is close to 0. So the values of tan theta is taken as theta. Okay, so that is tan theta equal to theta. Similarly, tan alpha is equals to alpha, that is equals to h by PO, and tan beta is equals to beta, that equal to h by PC. Tan gamma is equal to gamma, that equal to h by Pi. Now substitute this alpha, beta, gamma values in the above equation number 1. Okay, now we got the values of alpha, beta, gamma. Now substitute these values in the first equation. What is that first equation? 2 beta equal to alpha plus gamma. Okay, 2 beta is equals to alpha plus gamma. Okay, na? So here beta equal to what is there? H by PC is there. Okay, so beta is equals to h by PC is there. So that's why here 2 beta equal to alpha plus gamma. No? So 2 beta, 2 written where has this, and beta is equals to what is there? H by PC is there, right? H by PC, that equal to alpha. In the place of alpha, what we should write? Alpha is equals to h by PO. H by PO we are written, and plus gamma there. No, gamma is equals to what is there? H by Pi. H by Pi. Okay, now take h common. Okay, so in this all h is there, no? Take h common. So if we take h common, what we can write? H take common, then we can write 2 by PC equal to, take h common from this side also, h common, then we can write 1 by PO plus 1 by Pi. H get cancelled, then what we can write? 2 by PC equal to 1 by PO plus 1 by Pi. Okay, 2 by PC equal to 1 by PO plus 1 by Pi. It is equation number 2. Okay, so from this how can we show the relationship between image distance, object distance and focal length? Now we will discuss. To take the values with correct sign, follow the sign convention given below. Okay, so to get these values, we should follow the sign convention. So sign convention for okay, sign convention. What is that sign convention? Sign convention. See, all the distance should be measured from the pole. So here we are drawing ray diagram. We drawn ray diagrams for concave mirror, convex mirror. Okay, in this also we discussed one diagram. No, so here all the distance we should measure from the pole. Means all the distance means here object is there, from the object ray is falling on the mirror, and what happened? Reflecting, then image will form. No, so P to O is called as object distance. P to I, that is called as image distance. Object distance is showed by U, image distance is showed by V. Okay, P to C, the distance is called as radius of curvature. P to F, the distance is called as focal length. Like that we measure. No, so here object distance showed by U, image distance is showed by V. So like this, all the distance we should measure from the pole. Okay, next, the distance measured in the direction of incident light to be taken as positive, and those measured in the direction opposite to the incident light is taken as negative. For example, in this picture, okay, first figure is there. No, first figure, from the O, the ray is falling on the mirror at A, and after that, that is reflecting at I, the image will form. Like that we are discussing. No, like that in previous ray diagrams we discussed. In that also, incident ray, how it is going once you observe that path. Okay, so if we are measuring the object distance, image distance, radius of curvature and focal length in the direction of incident ray, then we should take that as a positive sign. Okay. For example, if you are measuring the object distance, image distance, center of curvature, okay, object distance, image distance, center of curvature, radius of curvature and focal length, if you are measuring opposite to incident ray, we should take an as negative sign. Okay, so here once you observe first figure, P to O distance is object distance, that is showed by U. P to I distance is image distance, that is showed by V. P to C distance is called as radius of curvature, that is R. P to F distance is called as focal length. Okay, so here incident ray, once you observe from the O, the ray is falls at a point A, no? In which direction it is going? That is going towards the left side. Okay, left side it is going. Okay, but here the object distance we are measuring, so all the distance we should measure from the pole means object distance, image distance, radius of curvature, focal length, this all we should measure from the pole. But here we are measuring the distance from P to O, means left to right. Left to right we are measuring the distance, object distance, but the ray is going from right to left, means these two are opposite to, then we should take it as a negative. Okay, like that. P to I, image distance, that is showed by V. Incident ray is going from O side, means right to left, but we are measuring the image distance P to I, left to right we are measuring. These two are opposite now, so that's why we should take it as negative V, like that we should measure. Okay now. Next, object height and image height. Do you know what is object height and image height? So in previous ray diagrams we discussed, in the ray diagrams we kept one object in front of a concave mirror or convex mirrors. Okay, arrow mark like that, that is object height. Then from the principal axis to arrow mark, one line we draw now, that is object height. Then image also formed now. So once you observe one ray diagram from concave mirror, okay, so on principal axis we kept to object, there we should draw on one line. Okay, from the principal axis to arrow mark line is there, no, that is object, that height is called as object height. Next, from the principal axis to downside one arrow mark is there, that image will form, that is image height. So like that, object height and image height, the two are positive if we measured upward from the principal axis. Okay, if we measure the object distance and image distance above the principal axis, then we should take as positive sign. If we measure the object distance and image distance below the principal axis, then we should take as a negative sign. Okay, so now we should substitute that values in the equation number 2. Okay, substituting the values of PC, PO and PI in the equation 2 according to the sign convention. So here PC is nothing but radius of curvature. Okay, once you observe the first figure, P to C distance is called as radius of curvature, that is showed by R. The radius of curvature is showed by R. So here the radius of curvature we should take as negative sign or positive sign, negative sign. Okay, why? Because incident ray is going from right to left, but we are measuring the radius of curvature distance left to right, that's why negative R. Same object distance, P to O distance is called as object distance, no? So that is negative U or positive U or negative U. Why? Because incident ray is going from right to left, but we are measuring the object distance left to right, that's why negative U. Image distance negative V or positive V or, so we are measuring the image distance P to I, means left to right, but incident ray is going right to left, that's why negative V. So now substitute this PC, PI and PO values in the equation number 2. Equation number 2, what we got? 2 by PC equal to 1 by PO plus 1 by PI. Okay, 2 by PC equal to what we can write? Radius of curvature. So minus R, 2 by minus R equal to 1 as it is. 1 by PO is there, no? 1 by PO means 1 by minus U. PO means object distance, that is U, no? Okay, 1 by minus U plus 1 by PI is there, no? 1 by PI. PI is image distance. Image distance is v, but here negative v, so 1 by minus v we can write. Okay, so from this take minus common. Okay, so here minus 2 by r equal to minus 1 by u plus 1 by v. Minus minus get cancelled. Then what will come? 2 by r equal to 1 by u plus 1 by v. We know that radius of curvature r equal to 2f. So that's why in the place of r substitute 2f. 2 by 2f is equals to 1 by u plus 1 by v. Okay, 2 get cancelled. Then what will come? 1 by f equal to 1 by u plus 1 by v. Okay, this is called as mirror formula. This mirror formula should be used according to the sign convention in every situation. Okay, so what is the use of this formula means? From this chapter we have some problems. Means he will give the object distance and radius of curvature and he will ask you to find out image distance. Okay, otherwise he will give image distance, so object distance and focal length, and he will ask you to calculate image distance. Then this formula will be useful to us.